Measuring angles. For our warm-up, we have towns A, B, C, and X. They're all located along a straight highway. Town B is between A and C. The distance from A to C is 41 miles. BC is 2 miles more than twice AB. We're going to write an equation and solve it to find AB and BC. And then second, town X is between A and B, 6 miles from A, and we'll find XC. So let's start by drawing a diagram. We have towns A, B, and C, and it told us that B was between A and C. Now it does not matter if it's drawn to scale or not. Just put B in there somewhere between A and C. It might end up being right directly in the middle. It might be really, really close to A. We don't know. Just put it on there somewhere so that we can get a diagram going. We know that the distance from A to C is 41 miles, all the way from A to C. And we're told that BC is 2 miles more than twice AB. So let's go ahead and call A to B X. And BC is 2 more than twice the distance from A to B. So let's call that 2x plus 2. So to solve for x, we're going to have x plus 2x plus 2 equals 41. So that gives me 3x plus 2 equals 41. Subtract 2 on both sides, we end up with 3x equals 39. So x equals 13. What that tells me is from A to B it's 13 miles. And from B to C is going to be 2 times 13 plus 2, that's 26 plus 2, 28 miles. If I add these two together, I should get 41. So let's check it real quick and make sure. 28 plus 13 is 41. So that's the answer to number 1. Now number 2 is saying that we have town X between A and B 6 miles from A. I'm going to do another diagram down here. I've got A and then X, and this is 6 miles. And we want to find the distance from X to C. From X to C, from A to C, excuse me, is 41. So from X to C it should be 41 minus 6, which is 35 miles. The objectives for this lesson are to measure angles with a protractor and to identify and use angle addition postulate. A protractor is used to measure angles. As on a ruler, the intervals on the protractor must be equal. We've got this item we call a protractor, this object we call a protractor, and on here it's going to have all these little intervals, and those intervals should be equal. Some of them have 2 sets of numbers on them. Let's see, I'll put a 170 and a 160. Now when you measure an angle, you're going to put the vertex right in the center and have one of the rays go out towards the 0, and then the other ray will go through another point on the protractor. To determine which set of numbers you want to use, I'm going to look at where I started. Since I started at 0 and moved in this direction, I'm going to use those smaller numbers. So this angle is almost 20 degrees. I'm not going to use that 160 and the 170. Now if my angle started on this direction and moved this way, so let's say I'm talking about an angle that's out here. This angle that I'm tracing over right now, that angle, the 0, is on towards the right, or excuse me, towards the left, going to the right, and so I'll use those larger numbers because my 0 needs to be at the bottom. And if I count along, it'll start 10, 20, 30, 40, etc. Suppose that the vertex V of angle AVB is placed in the center point of a half circle with coordinates from 0 to 180. So just like I drew just a little bit ago, we've got this half circle, 0 to 180. Okay. Some of those protractors have 0 to 180 on the other side also. So we'll just look at this half and we'll look at the other half later. Intersect the half circle, so I've got to have A, V, B somewhere in here. A, V, B. To find the measure of that, I need to find the distance, or I'm going to figure out the interval length here. Now, a lot of people find it easiest to put one of your rays on 0. If it's not feasible, if you're not able to do that, you'll still be able to find the measure of your angle by finding the distance between those two parts that it does cross, or the two spaces that it crosses. So what this is saying is that if this is A and this is B, the measure of this angle is just the absolute value of the difference between those 2 points. Now, I said we'd look at the other side. It's going to work the exact same. I have 0 over here. If you put that angle, one of the rays at 0, and then move your way up, the measure of that angle is going to be the distance between 0 up to where that other ray goes through the protractor. Use a protractor to find the measure of angle CAB. To do this, you're going to make sure that the 0 on your protractor is going to go through and line up right at the base. Now, some of these protractors you have are going to go past B. Some of them are going to be smaller. Doesn't matter if your protractor doesn't, if the ray doesn't go through your protractor, just slide that protractor up a little bit and trace it or extend it out like I did here, so that the line or the ray does go through your protractor. There's nothing wrong with extending these lines out so that it's the right size for your protractor. And you're going to go ahead and put your protractor on here so that the 0 is right at A, the middle part, is right at A, and 0 lines up with ray AB. We're going to measure where angle C is at. So this is my 0 point. It's going up in this direction, and it should be about 120 degrees. Angles, like segments, are congruent if one can be moved onto the other so that they match exactly. So I should be able to take an angle, and if I'm going to say they're congruent, have another angle, cut them out, stack it on top, they should be perfect. Tick marks, and there's several different kinds of tick marks. Some notation that you'll see will put little lines through this. So you'll have the curve, the arc, and then a line through both of those to show that they're congruent. If you've got multiple angles on a drawing, and I want to say that these first 2 angles are congruent, and the second 2 are congruent but not congruent to the first 2, then I have 2 tick marks. Another type of tick mark you might see is where we take, and instead of putting lines, you just do 2 arcs. And so the ones with 1 arc, the angles with 1 arc are congruent. So for instance, A and B. And then the angles with 2 arcs are also congruent, say angles C and D. So there's a couple different notations you might see. If 2 angles have the same measure, then they are congruent. If 2 angles are congruent, then they have the same measure. To use this, or to see how we can use this, I've got this notation. The little m means measure, so this is saying if the measure of angle ABC equals the measure of angle DEF. We use equal when we're talking about numbers or numerical values, so we're talking about an angle being 32 degrees, an angle being 45 degrees. It's an actual value. What we can say is if their measures are equal, then the angles, angle ABC, is congruent to angle DEF. And if we know that angle ABC is congruent to DEF, we can say that the measure of angle ABC is congruent to the measure of angle DEF. If point S is in the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR equals the measure of PQR. Okay, that's very confusing unless we draw a picture. So I've got S is in the interior of PQR. I've got the measure of P, oh, I better label me P, Q, and R. S is in the interior, and I'm going to look at the measure of PQS. So PQS is this angle. I'm going to name it angle 1. And SQR is the angle right next to it, SQR, angle 2. So all this is saying is that angle 1 plus angle 2 is equal to that entire angle. So you can break it up into parts, and you can add those two angles together, angle PQR. Complementary angles are two angles whose measure have a sum of 90 degrees. And you can say if angle 1 and 2 are complementary, you can say that angle 1 is the complement of angle 2. And supplementary are two angles that have a measure of 180 degrees when you add them together. And those are supplements of each other. Complementary angles have to add to equal 90. They can be adjacent. They don't have to be adjacent. So here would be an example of two adjacent angles, angle 1 and angle 2, where they are complementary because they add up to be a 90-degree angle. Supplementary angles, here would be an example of supplementary angles, angle 3 and angle 4, because when I add them together I'm going to get 180 degrees. They can be adjacent, but they don't have to be adjacent. Name all the complementary and supplementary angles below. So I'm going to start with A. A is 60 degrees. In order for me to have a complement with A, I need to be able to get 90 degrees. 60 plus 30 is 90, so that tells me that A and B are complements. They're complements because they add to equal 90 degrees. B, 30 degrees, the only complement it's going to have is a 60-degree angle because the only number plus 30 plus 60 is the only way I'm going to get 90 when I start with 30. I want to add two together. To get supplementary angles, I'm looking to get 180 degrees. If I look at A is 60, and I notice C is 120, that gives me 180. So I can say that A and C are supplementary angles. If two angles form a linear pair, then they are supplementary. Linear pair, all linear pairs are supplementary, but not all supplementary angles are linear pairs. Here's the difference. A linear pair means that those two angles actually make a line, so they have to be touching. This is a linear pair that I've drawn. Angle 1 and angle 2 form a linear pair, which means they make a line, and they're adjacent. Because they make that line that's 180 degrees, that makes them supplementary. Because they're adjacent, that's what makes them a linear pair. Now if I have angle 3 and angle 4, they're not touching, they're not adjacent, they don't have a common ray, they don't have a common vertex. So 3 and 4 are supplementary, but they're not a linear pair. So in order for it to be a linear pair, those two angles have to be adjacent and form a line. A right angle is an angle whose measure is 90 degrees. We name right angles, or we label right angles, with a little square in the corner, and that shows whoever's looking at the drawing that it is a 90-degree angle. An acute angle is an angle whose measure is less than 90 degrees. And an obtuse angle is an angle whose measure is greater than 90 but less than 180. So acute angles are going to be anything that's smaller than 90 degrees. And obtuse angles are going to be any angle that's greater than 90 degrees. And if you have a piece of paper has 4 right angle finders. This is 90 degrees, this is 90 degrees, 90 degrees, and 90 degrees. And so if you've got an angle and you're trying to figure out if it's a right angle, and you don't have a protractor around, you just hold this up to your angle, put one ray on one side of the paper. If it's larger than the paper, then it's an obtuse angle. If it's smaller than that corner, it's an acute angle. And if it's right on the angle, it's a right angle.